Hi everyone! As promised, in this video I'm going to show you how you can use your knowledge of the vertex and of intercepts to graph parabolas. So our first example is to look at this function. It's definitely a quadratic polynomial. It's degree 2, so we know it looks like a parabola. It comes from the parent function x squared. And our goal is to find the x-intercepts, y-intercept, vertex, and graph it. So maybe the first thing we can do is to put it in vertex form. So in order to put it in vertex form, we want to complete the square, but it actually turns out we don't need to complete the square in this example because it's already a square. See how it factors? We have that f of x equals x plus 1 quantity squared. If I tried to complete the square, what I would end up doing is I would add something and then subtract that same thing so that I'm adding 0. But in this slot, I would put 2 divided by 2, which is 1, and square is 1 squared, which is 1. And the same thing here. So I have x squared plus 2x plus 1. This is the part that's x plus 1 squared. And what's left over is just 0. So it's clear to see this one was already a square. So what does this tell us? It's x plus 1 quantity squared plus 0. Remember that the vertex form was x minus h squared plus k, and the vertex was hk. So here our vertex is negative 1, 0. So this helps us when we're trying to figure out the graph because we already know a few things. Now we have a point that's definitely on our graph. Negative 1, 0 is on the graph. So all I need to do is find 2 more points that are on the graph. And that's because a parabola is determined by 3 points. Just like a line, once you know 2 points, you can connect them, and that gives you a unique line. Parabola, once you know 3 points, you connect those. That gives you a unique parabola. So we just need to find 2 more points and in order to graph it, and the problem gives us a hint as to which points we might use. So we can find the x-intercepts and the y-intercepts. So to find y-intercepts is really easy. We just plug in 0 for x. So this is a review. We did this in chapter 1. So when I plug in 0 for x, I'm looking for f of 0, which is 0 squared plus 2 times 0 plus 1, and that's just 1. So that tells me that 0, 1 is my y-intercept. 0, 1. Turns out I already have my x-intercept because the x-intercept is where the y value is 0. So I would solve for it by solving for x when I set the equation equal to 0. So 0 equals x squared plus 2x plus 1. We solve these types of equations by factoring. So that tells us that 0 equals x plus 1 squared. This is true when x is negative 1, which tells us the x-intercept is negative 1, 0. But I told you that you need 3 points in order to determine the parabola. So we need to find one more. One good way to do this is by using symmetry. I know that a parabola is symmetric across the axis that goes through the origin. This side is a reflection of this side. So if I know a point here, which is 1 to the right and 1 up, I know that's on my parabola, then I know that there should be a point that's 1 to the left and 1 up. So this gives me 3 points which determine the graph of my function. So there you go. Let's try another example, and I'll put my face away so you can see the notes. So here we have f of x equals 2x squared minus x plus 1. We want to find the vertex and to graph it. So this one, it turns out that the vertex is actually quite messy to find, but we'll complete the square to do it. So the first thing I'll do is I want to get rid of that 2, so I factor it out of the entire expression. So I have x squared minus 1/2 x. Then I'm going to add something, subtract that same thing, and then I have plus 1/2, since I also factored the 2 out of this one. Let me write that a little darker so you can read it. Okay, so what do I put here? I put 1/2 divided by 2 is 1/4, and then squared is 1/16. So then I must also add 1/16. This is the part that's going to be my perfect square. But I should distribute the 2 to this leftover constant stuff. So I have 2 times x squared minus 1/2 x plus 1/16 minus 2 times 1/16. Well, I'll do plus 2 times negative 1/16 plus 1/2. So this is going to be 2 times x minus 1/4 squared. And this last term, if you work it out, it ends up being 7/8, because 2 times 1/2 is 1, and then I'll subtract off 1/8, which is the same as 2/16. So this tells me that the vertex is 1/4, 7/8. So I start to graph it. Let me put my graph a little closer here. And we don't need all that space below. Let's move that there. So if my vertex, let's say 1 is here, then here's 1/2, here's 1/4, and if 1 is here, then that's 1/2, that's 3/4, so that's 7/8. So the vertex is at 1/4, 7/8. I need 2 more points in order to graph this. So one easy one to find is the y-intercept, and then we'll use symmetry again. So the y-intercept is just when I plug in 0 for x, so I get 0 minus 0 plus 1, so the y-intercept is at 0, 1, so that's right there. And now I'll just use symmetry again. So I went left by 1/2 and up by 1/8 from the line of symmetry, so to get another point I can go over, or left by 1/4 and up by 1/8. So in order to get another point on the graph, I'll go to the right by 1/4 and up by 1/8. And so now I connect these up, and that gives me the graph of my parabola. And we can always check this in our calculator if we're not sure. So we're trying to do 2x quantity squared minus x plus 1. We'll check out the graph. And it looks pretty close to our graph, but the scale's rather different. So we could change the window so it looks more like ours. Let's go -2 to 2 on the x's and -2 to 2 on the y's. Check that out. So this intercept is 0, 1. We can check that, 0, 1. We can estimate the minimum, 0.25, 0.8. That's about 1/4 and 7/8. And then if we go over to 1/2, so we can do second trace value, 0.5. That should be up to 1. That's this point. So it looks good. It matches what we came up with. All right, one more example in this video. So we want to find the vertex, x-intercept, and y-intercept of 2 times x minus 2 quantity squared minus 8. So this is already in vertex form, which makes our life easy. The vertex is at 2, -8, hk. Okay, so that's pretty nice. Now to find the y-intercept, we plug in 0, so we do f of 0, which is going to be 2 times 0 minus 2 is -2, quantity squared minus 8. So Negative 2 squared is 4. 4 times 2 is 8, so we end up with 8 minus 8, which is 0. So that tells us the y-intercept is 0, 0. To find the x-intercepts, we need to solve the equation, which we obtain by setting the equation for the parabola equal to 0. So I could multiply this out and factor it, that's what we normally do, but since it's in this completed square form, we can actually solve it by using perfect squares. So I'll do it that way. I have 2 times x minus 2 quantity squared equals 8. So then x minus 2 quantity squared equals 4. So then x minus 2 either equals 2 or it equals negative 2. In this case, x is 4, and in this case, x is 0. So this tells us that our x-intercepts are 4, 0. This says when I plug in 4, I get out 0, and 0, 0. So our x-intercept and y-intercept end up being aligned here, and our vertex is at 2, negative 8. So if I look at the graph, I have 3 points. Here's 0, 0, the x-intercept. 1, 2, 3, 4. Here's 4, 0, the y-intercept. And 2, negative 8 is going to be way down here for our vertex. And you just connect them up. So the basic idea here, the key in doing these graphing examples, is that you only need 3 points to graph a parabola. For more complicated functions, you need more than 3 points, but for parabolas, you only need 3. So some good ones to use are the vertex. Then you could find another by getting an intercept. So a y-intercept is easy, you just plug in 0. X-intercepts are also pretty easy. So then find an intercept. And then, like in these first two cases, we'll use symmetry to get another point, unless the intercepts are enough. So you only need to use symmetry if the intercepts don't give you 2 additional points different from the vertex. In these examples, the intercept, we could only find one intercept because there weren't x-intercepts, so there was only a y. And in this case, same thing, there was only one x-intercept, so just finding the intercepts wasn't enough. This case, finding the x-intercepts was enough to give us 3 points. So I hope that this helps you with the graphing problems on the web work. This is a really important skill, and it puts together a lot of the things that you already know, like factoring and solving quadratic equations and finding intercepts. And using vertex forms. So it's a culmination of a lot of your skills. Good luck with the web work, and there's one more video on quadratic polynomials to come.